Hello everyone, I Dr. Megha Mishra welcome you all to the Swayam online course on Introduction to Knowledge Representation and Reasoning. In today's lecture, we are going to learn about Introduction to Knowledge Representation and Reasoning. Machine perform tasks similarly to how humans do, but the process is fundamentally different as machine lack consciousness and self-awareness. Machines rely on computer programming and algorithms to process and interpret information, enabling them to simulate human like understanding and reasoning. Here is a brief overview of how machine perform tasks. Like data input, machine receive input data through sensors, user interactions or other sources. This data can be in various forms such as text, images, audio or numeral values. Data processing. Before processing the data, machine often need to pre-process it, which involve cleaning, transforming and organizing the information to make it suitable for analysis. Machine learning is one of the most common approach for machine to perform tasks is through machine learning. In supervised learning, machines are trained on labeled data where the input and the desired output are provided together. The machine learns patterns and relationship in the data to make predictions or classifications on new unseen data. Various algorithms are used depending on the type of task at hand. For example, convolutional neural networks are commonly used for image recognition tasks, while recurrent neural networks are used for sequential data like natural language processing task, reasoning and decision making. Machines can reason and make decisions based on the patterns and information they have learned from the training data. For example, an AI system can analyze historical data and patterns to predict future trends, real world actions based on their analysis and decision making processes. Machine can interact with the real world. This can involve controlling robotics arm, responding to user queries, generating recommendations or making decisions in various domains. Machines can also learn from their interactions with real world by receiving feedback on the outcome of their action. They can continuously improve their performance through reinforcement learning or updating their algorithms based on new data. It is essential to note that while machines can perform specific tasks with remarkable accuracy and speed, their understanding is fundamentally different from human understanding. They operate based on patterns and statistical inferences rather than true comprehension of knowledge. This is often referred to as narrow AI or weak AI, as opposed to the broad cognitive abilities and general intelligence represented by humans. Nonetheless, advancement in AI and machine learning continue to bridge the gap and lead to more sophisticated applications in various domains. Knowledge representation is the study of how an intelligent agent believes, intentions and judgments can be expressed in a way that allow for automation reasoning. In similar terms, it is about teaching machine to understand and think. The humans knowledge representation is very crucial because it forms the backbone of AI reasoning. Just like humans, machine need a way to organize and process information to perform various tasks, whether it is understanding natural language, recognizing objects in images or making predictions. Knowledge representation is the key to achieving all these capabilities. One of the primary purpose of knowledge representation is to model intelligent behavior for an agent. Picture an AI powered virtual assistant. It needs to comprehend your queries, understand the context, and respond appropriately. This is possible through well structured knowledge representation techniques, allowing the AI to reason and provide meaningful responses. There are various methods of knowledge representation, each with its strengths and weaknesses. Some common approaches include semantic networks, where concepts are connected through relationships, and logical formalism, which involve using rules and symbols to represent knowledge. While knowledge representation is powerful, it is not without its challenges. AI researchers often face difficulties in representing uncertain or ambiguous information, dealing with incomplete data, and managing the vast complexity of knowledge in real world scenario. Knowledge representation allow machines to grasp information from the real world in a structured manner. It is like building a roadmap to navigate the complexities of our surroundings, and knowledge representation reasoning enables the machine to reason effectively using this knowledge. Knowledge representation and reasoning unlock the door to human like intelligence in machines. By instilling AI system with the ability to reason, learn, adopt like humans, we are ushering in a new era of AI that genuinely understand and acts intelligently in our ever changing world. As we continue to advance knowledge representation and reasoning, we are paving the way for a future where machines become trusted companions, working alongside humans to solve global challenges, enhance our lives, and push the boundaries of knowledge. AI systems understand and categorize objects, whether they are physical entities like trees and cars, or abstract concepts like love and justice. Knowledge representation enables machines to capture and reason about events from simple actions like walking or eating to complex interactions in social scenario or scientific experiments. Just like human improve through experience, AI systems too can learn from past performance. Knowledge representation allow machines to store and utilize data on past experience, enabling them to find, tune their behaviors, and make better decisions in the future. Facts are the pillars upon which knowledge is built. Knowledge representation ensures that AI systems can store and reason about factual information, providing a reliable information for their decision making and problem solving abilities. Meta knowledge is knowledge about knowledge itself. In artificial intelligence, this means understanding what the system knows, the confidence level of that knowledge, and the sources of information. Knowledge representation enables machine to introspect and reason about their own knowledge, leading to more robust and accountable AI systems. Finally, at the core of intelligent machines lies the knowledge base, a repository where all types of knowledge are organized, linked, and made accessible to the AI. The knowledge base, fueled by knowledge representation, serve as the backbone of AI reasoning and decision making. Declarative knowledge, we can say that this type of knowledge consists of concepts, facts, and objects and is expressed in declarative sentences. Declarative knowledge focuses on what is true rather than how to do something. For example, the capital of France is Paris. Structural knowledge refers to the understanding of relationship between concepts and objects. It provides the framework for organizing and connecting various pieces of information. For example, understanding that addition and subtraction are inverse operations. Procedural knowledge is the knowledge of how to do something. It includes rules, strategies, procedures, and step by step instructions to accomplish a specific task or solve a particular problem. For example, knowing how to ride a bicycle. Meta knowledge is a knowledge about other types of knowledge. It involves awareness of what one knows, how one acquires knowledge, and how to use that knowledge effectively. For example, recognizing that using mnemonic techniques can help in memorizing information more effectively. Heuristic knowledge represents the insights and strategies gained from experience and expertise in a particular field or subject. There are often informal rules or thumb or shortcuts used to make decisions or solve problems efficiently. For example, a chess player using their experience to recognize common opening moves and patterns. Understanding the different types of knowledge can help us recognize the diversity and complexity of human cognition and learning process. These types of knowledge often work together in various ways to facilitate understanding, learning, and problem solving in our daily lives. Artificial intelligence systems often consist of various components that work together to display intelligent behavior. Perception component allow the AI system to perceive and interpret the world through sensors or data input. It involves gathering and processing information from the environment such as images, sounds, text or other sensory inputs. Learning is a crucial aspect of AI systems. It involves the ability of the system to improve its performance based on experience or data. Machine learning techniques such as supervised learning, unsupervised learning, and reinforcement learning are commonly used to enable AI system to learn from data. In knowledge, representation, and reasoning, AI systems need a way to represent and store knowledge. Knowledge representation involves structuring information in a manner that the AI system can understand and reason with. Reasoning enables the AI system to draw inferences and make decisions based on the available knowledge. Planning is the process by which AI system determines a sequence of actions to achieve specific goals or objectives. It involves considering different courses of action, evaluating their potential outcomes, and selecting the best approach. Once a plan is generated, the AI system needs to execute the actions in the real world environment to accomplish its objective. Once a plan is generated, the AI system needs to execute the action in the real world environment to accomplish its objective. This might involve physical actions, interactions with users, or other external systems. The perception component utilizes various sensors, data channels, or inputs sources to gather data from the surroundings. For instance, it may include cameras, microphones, temperatures, sensors, GPS receivers, and other sensors relevant to the specific AI system purpose. When dealing with audio data, the perception component can process the input from microphones or other audio sensors to identify the source of noise or sounds present in the environment. This functionality is essential in applications such as sound recognition, speech processing, and acoustic monitoring. The perception component can also be designed to monitor the health and status of the AI itself. By analyzing internal signals, diagnostics, or sensors data related to the system operation, it can detect if any components are malfunctioning or if the system has been physically damaged. The data gathered and processed by the perception component contributes to the AI system's understanding of the environment. This understanding enables the system to recognize objects, identify patterns, interpret events, and make information decisions based on the available information. In summary, the perception component plays a vital role in an AI system ability to perceive and interpret the environment by retrieving data, identifying noise sources, and checking system health and fostering environmental understanding. It forms the foundation for the AI system intelligent behavior and decision making process. Machine learning techniques such as supervised learning, unsupervised learning, and reinforcement learning allow the AI system to learn patterns, relationships, and representations from the data. Unlike traditional programming, where explicit rules are manually coded, the learning components enable the AI system to learn from examples, experiences. This empowers the system to generalize and make predictions or decisions on new unseen data. Learning is an interactive process in which the AI system continuously improves its performance over time. As it encounters new data and learn from it, it can refine its understanding, decision making abilities. The learning component facilitates the acquisition of knowledge from various sources, including labeled data, unstructured text, user feedback, or even other AI systems. Learning can lead to more efficient search algorithms and strategies, allowing to AI system to find solutions or make decisions more quickly and effectively. By combining the perception component, learning component, and knowledge representation and reasoning component, AI system can represent intelligent behavior. The perception component captures the data from the environment. The learning component acquires knowledge from the data, and the knowledge representation and reasoning component organizes and processes that knowledge to make informed decision and display human-like intelligence. Planning is the process of generating a sequence of actions to achieve a specific goal based on the knowledge representation and reasoning. By the knowledge representation components, it involves analyzing the initial state of the environment, identifying the preconditions, effects of various actions, and determining an optimal feasible path to reach the desired goal. Execution state: once the planning phase is completed and a sequence of actions has been generated, the execution components take over. It is the responsible for carrying out the planned actions in the real world environment or simulation. The execution component interacts with the systems, actuators, sensors, and effectors to implement the actions specified in the plan. By integrating the planning and executing components with the knowledge representation reasoning capability, AI system can perform the goal oriented task automatically, making them versatile and capable of handling real world scenarios with uncertainties, changing conditions. Knowledge forms the foundation of intelligence in humans. Our ability to reason, solve problem and make decision is built upon the vast reservoir of knowledge we accumulate over time. Similarly, in artificial intelligence, knowledge representation and acquisitions are essential for enabling intelligent behavior in AI agent or subsystems and systems. Knowledge allow AI agents or systems to demonstrate intelligent behavior. By possessing relevant knowledge, AI system can reason, learn, adopt and make informed decisions that resemble intelligent actions in the real world. AI systems can learn from data and experiences much like humans do. By acquiring knowledge from training data, AI systems can generalize from examples and make predictions or decisions on new unseen data. Continuous improvement in AI system can continuously improve the performance by updating and refining their knowledge based on new data and experiences. This iterative process of learning and adaptation is a landmark of intelligent system. Knowledge plays a central role in shaping intelligence, be it in a humans or artificial intelligence. The possession and effective use of knowledge enable AI agents or systems to demonstrate intelligent behavior accurately, respond to inputs, learn from experience and adapt to new challenges. As AI research advances, knowledge representation and acquisition will continue to be pivotal in creating more sophisticated, capable AI systems. Knowledge is a critical component in the decision making process of an AI system. Without knowledge, an AI system would lack the information necessary to make informed and intelligent decision based on the input from the environment. Now, let's move on to the techniques of knowledge representation in AI knowledge representation. It is the process of structuring and organizing information in a way that enables an AI system to reason, infer and draw conclusions. It provides a means for AI system to store, process and utilize knowledge effectively. The choice of representation depends on the specific problem domain, the complexity of knowledge and the requirement of the AI system. Effective knowledge representation is crucial for creating intelligent AI system capable of reasoning, problem solving and making informed decision in real world scenario. Effective knowledge representation in AI is essential for building intelligent systems that can understand, reason and make decisions based on the available knowledge. The choice of representation depends on the specific problem domain, the complexity of knowledge and the requirements of the AI application. A well-designed knowledge representation enables AI system to represent intelligent behavior and solve complex tasks efficiently. Logical representation in AI relies on definite rule and propositions, which are statements that are either true or false. These rules are expressed using formal logic such as predicate logic or propositional logic, ensuring a clear and unambiguous representation of knowledge. Logical representation is a powerful tool in AI for expressing complex knowledge and enabling intelligent behavior by employing logical rules, clear syntax and sound semantics. AI systems can engage in reliable inference, problem solving and decision making. Logical representations are extensively used in knowledge based system, expert system and other AI applications where precise reasoning and unambiguous knowledge representation are crucial. Syntax focuses on the proper arrangement of symbols in a representation language, ensuring that the expressions are well formed and adherent to the rules of the language. Semantics, on the other hand, concerns the meaning and interpretation of these expressions, allowing for the assignment of truth values and relating the expressions to real world situations or concepts. Both syntax and semantics are essential for effective knowledge representation. The correct syntax ensures that the knowledge is expressed in a valid, unambiguous form, while semantics give meaning to knowledge, enabling reasoning, inference, and the accurate interpretation of the represented. Logical representation provides a formal and systematic way to perform logical reasoning. It allows us to deduce new information based on existing knowledge and a set of rules or axioms, formal basics for programming. Logical representation serve as the foundation for programming language and artificial intelligence systems. Many programming languages such as Prolog are based on logical principles, enabling developers to express complex relationship and conditions in a structured manner. Automated reasoning in logical representation can be used in automated reasoning system to solve problems, verify theorems and prove correctness in various domains such as mathematics and computer science. Restrictions and complexity in logical representation may have limitations in expressing certain types of knowledge or complex relationships. Real world scenarios often involve uncertainty, imprecision and vague concepts which can be challenging to represent using strict logical rules. Natural language gap, we can say that translating the natural language into logical representation can be difficult, especially when dealing with ambiguities and context dependent meaning. Natural language is rich and dynamic, making it challenging to capture all data using formal logic. In some cases, logical inference can be computationally expensive, especially when dealing with large knowledge base or we can say complex logical expressions. The process of deriving conclusions from logical representations can be time consuming and resource intensive. Semantic networks are an alternative knowledge representation technique to predicate logic. They provide a graphical way to represent knowledge using nodes, also called concepts or entities, and arcs, also known as edges or links, to represent relationship between these nodes. Semantic networks are commonly used in artificial intelligence, cognitive science and knowledge based system. Nodes in semantic network represent objects, concepts or entities. Each node corresponds to a specific concept or item in the domain being represented. Arcs, which we can say edges or links in the semantic network, represent the relationship between nodes. These relationships can be various types such as is a relationship, part of, has, related to and so on. The is-a relation is used to represent a hierarchical relationship between concepts, indicating that one concept is specific type of another concept. For example, if we have a concept animal and another concept cat, we can represent the relationship as cat is a animal, indicating that here is one example of semantic network representation. Car is a kind of pickup truck and BMW is a car, and both has headlights. Semantic networks offer a more natural and intuitive representation of knowledge, similar to how human organizes information in their minds. A frame is a data structure used in artificial intelligence and knowledge representation to describe entities or objects in the world. It represents a stereotype or a template for a particular class or object or situations, and it consists of a collection of attributes and their corresponding values. So, in this class mainly we have discussed about the knowledge representation, types of knowledge, knowledge representation in AI, and issues in knowledge representation with their examples. Also, the relation between knowledge and intelligence has been discussed in detail with their example. In the next lecture, we will learn about propositional logic in knowledge representation and reasoning. With this, we will end up our today's lecture. Thank you for your patience, and we will meet in next lecture. Thank you.